The subsystem, your system, your VMs, everything else.
That's not going to solve the purpose of saving the cost of
No.
redundancy.
Cost saving is always there. We talk about bare metal. You think about renting 200 square feet of space and 10% used by this resource. Same 200 square feet of space. 25 companies use the same, making 90% usage. We talked about green, we talked about power saving, we talked about saving of data center space, and 25 machines being bought. We love it because from hardware sales point of view, but from CapEx point of view, customer.
I had a question.
Thank you.
Just to add to that. So was the failure in Virginia, DMV, and others we faced a few weeks back? No, just that's like that is the real. See, we can talk of ROI and things like that, but impact. So you have to have folks from DMV work in the weekends and things like that. So talk a little bit about it. Could be done now or later if you have it in the presentation. That's something it's like a real life issue. We can talk about mitigation and like fail safe, replication. Why that didn't work there or things like that.
Okay, I know that based on what I read in the paper. I mean, actually, yeah, DMV, Commonwealth of Virginia is a customer of mine. I read about it. I was told, the paper really talked about. Their SAN subsystem, right, really had an issue. Other than that, I am not really sure where exactly the issue was. I don't think I made this right. Yeah, I don't know where the issue was. I mean, they were not able to really access their data, right? I mean, multiple agencies that really shared the same SAN were not able to access their data. So that's what really caused their systems to really go down, right? I mean, pretty much if you can't access it. I'm not really sure where exactly the problem was. I mean, if you know more about it, I mean, certainly we can discuss that.
That was another thing. So basically, when you abstract it to that level, so this is one of the issues that even I don't know details about it. And my whole idea here was, so when you have abstracted to that level of, like it's abstracted, it looks nice when you model it, when you present it, you can really do a good job. But when you're running like 25 agencies, like, connecting to this data source or something, and then you're having some issues there, nobody can point it. So then there is...
See, technology is one thing, implementation is another, right? How things really are implemented is very different from what the technology gives you, the functionality provided by the technology. Doesn't mean that everybody, this gives you the ability to really make changes without impacting the application. But obviously, if the virtualization layer really has a problem, then you do. But not everybody really does things like that, right? I'm sure now there is going to be, the CIO is already talking about replicating that data, making sure that there is never a single point of failure, those kind of things. Now they are talking about it, right? But prior to it, there was a single point of failure. I mean, that was the main. So you could really use these technologies to ensure that there aren't single points of failure, right? But they hadn't done that.
Even it takes ages to really test the single point of failure. Like I work with USPS, and recently we are trying to keep up with aggregation and all. Like we talked about, we have the clustering and all. Like we have nodes getting evicted, and don't know underneath because they're trying to upgrade the software just to get rid of that error. But they're unable to. They kind of what they started was consolidating environments and servers. The primary reason was for green. The server room was getting so much heated and so many servers. They cut down significantly. They came down probably 10% of the servers from what they had. But now as they are bringing the production systems in, as the load is going up from 10-15% to 40-50%, the underneath layer, like aggregation layer, like clustering software, is not performing like what they expected. So these are the challenges, of course, they are there. They have a disaster recovery side, big, huge, but like thousands of applications, like failing over is also big risk. Like you cannot test it in a year too. Like it takes like really good decade like to test completely. They have a bubble kind of thing, like they want to float the all IPs from one center to other center. It's not easy to test. Like I've been like involved, like, but it's not easy. It takes like thousands and thousands of people like involved. Like so.
See, there are two components to that. One has to understand. He's talking about virtualization technology from one spectrum of business. You're talking from another spectrum of business. I'll give a classic example. Because I got 278 customers worldwide. I was talking to them. There are customers whose business is extremely critical. Classic NASDAQ. You know this up. Am I going to do send hypervisor on NASDAQ? No, we'll be stupid, right? See here, I cannot afford a downtime of a second. That's a business criticality driver. At that point of time, NASDAQ is willing to invest $100 million to protect their transactions. Is DME that critical? No, honestly no. Okay, DME guys in friends in government goes home, peacefully sleeps, even if the system crashes at 8 o'clock. They damn don't know even, right? So in that case, what makes cost of operations sensible? Their CIO has a budget where he cannot afford to spend $100,000 more. Now we go to virtualization. He says, okay, business goes down what? Let it be down for 3 days. Here, if that was the case in NASDAQ, we would have had multiple SVCs, symmetric applications. If you see, have you ever come across Visa network going down? Have you ever come across ATM network going down? Not that they have not gone down, they have gone down. I was working for Visa. If this route goes down from Bombay to London, it will go through Singapore to London. So it will ping every 2 seconds to see is this line up or not. If it's not up, immediately it will reroute. But there's a cost of implementation of that. So you have to understand, here the objective of virtualization is optimization. Optimization of resources. Reduction in cost. Reduction in operating cost. And they're giving back the benefit back to the users, end users. That's the driver. So your driver is extremely opposite, where I'm going to have a replicated disaster recovery system, I'll have a redundant network system, redundant switches, etc.
Yeah, thank you. Yeah, I'm told that I have another 15 minutes to go, so I need to really flip through these charts. Yeah, this is really, I don't want to really spend too much time on this. I mean, I just want to really bring up the fact that, this virtualization in as a technology has been around for, for a long time. I mean, since 1960s. So what are the kinds of things that we really virtualize? It's really servers. I mean, we virtualize hardware, operating system, applications on the servers. We virtualize storage, disk, tape, files. We virtualize clients. On the client side, actually, it's application OS and hardware. Network, I mean, we virtualize the network fabric. And then application infrastructure itself is virtualized. Right? So if you really take a comprehensive view of virtualization, I mean, this the totality of virtualization, the big circle really says, okay, there is part of it that really impacts the client desktops, and the others really are on the data center side. Right? So on the client desktop, you really have desktop virtualization and application virtualization. Whereas on the in the data center side, on the server side of the house, you really have server virtualization, storage, network virtualization, and application infrastructure virtualization. They all really are more applicable to the data center side of the house, whereas the desktop and the application, part of the application virtualization is impacting the client side of the house. again, I mean, I think we have talked about these things. What is server virtualization? Consolidating multiple servers into fewer servers, creating multiple virtual servers on a single physical server. I mean, going both ways.